Let's explore how to perform residential load calculations using both the standard and optional methods. We'll break down 2 example problems step by step to help you understand the process. Firstly, let's tackle the first question using the standard method. This involves a 2300 square foot duplex, with each unit containing 2 8 kilowatt ranges, 1 5 amp garbage disposal, 1 11 amp dishwasher, 1 3 kilowatt hot water tank, 15 kilowatt heat, and 5 21 amp 240 volts air conditioning units. The goal is to determine the total load in amps. Step 1 is to calculate the appliance load in watts. For the ranges, each unit is 8 kilowatts, which equals 8000 watts. So we have 2 units at 8000 watts each. The garbage disposal is rated at 5 amps. To convert this to watts, we multiply the amperage by the voltage, assuming a standard 120 volt supply. So 5 amps times 120 volts equals 600 watts. Next, the dishwasher is rated at 11 amps. Again, multiplying by 120 volts, we get 11 amps times 120 volts, which equals 1320 watts. The hot water tank is 3 kilowatts, which is equal to 3000 watts. The heat load is 15 kilowatts, or 15,000 watts. Finally, we have 5 air conditioning units, each drawing 21 amps at 240 volts. To find the wattage per unit, we multiply 21 amps by 240 volts, resulting in 5040 watts per air conditioning unit. Since there are 5 units, the total air conditioning load is 5040 watts times 5, which equals 25,200 watts. Step 2 involves calculating the total appliance load. This is done by adding up all the individual appliance wattages. So, we add 8000 watts for the first range, 8000 watts for the second range, 600 watts for the garbage disposal, 1320 watts for the dishwasher, 3000 watts for the hot water tank, 15,000 watts for the heat, and 25,200 watts for the air conditioning units. Adding these all together, we get a total of 61,120 watts. Step 3 is to calculate the ampere draw. This is done by dividing the total wattage by the voltage. Since most of these appliances, excluding the air conditioning, operate at 240 volts, we'll use 240 volts for the calculation. So amps equals watts divided by volts, which is 61,120 watts divided by 240 volts. This gives us approximately 349 amps. Therefore, the total load for the duplex unit calculated using the standard method is 349 amps. Now, let's move on to the second question, which uses the optional method. This involves a 2000 square foot 10 unit multi-family building. Each unit has a 7 kilovolt amps range, a 1.2 kilovolt amps dishwasher, a 0.6 kilovolt amps garbage disposal, an 18 amp 120 volts air conditioning unit, and a 2.5 kilovolt amps 240 volts hot water tank. We are instructed not to include any house or laundry loads in this calculation. Step 1 in the optional method is to calculate the kilovolt amps loads. The range is already given as 7 kilovolt amps. The dishwasher is 1.2 kilovolt amps, and the garbage disposal is 0.6 kilovolt amps. For the air conditioning, we need to convert the amperage to kilovolt amps. Each unit draws 18 amps at 120 volts, which is 18 amps times 120 volts, equals 2160 volt amps, or 2.16 kilovolt amps per unit. Since there are 10 units, the total air conditioning load is 2.16 kilovolt amps times 10, which equals 21.6 kilovolt amps. The hot water tank is 2.5 kilovolt amps. Step 2 involves calculating the total kilovolt amps load. We add up all the individual kilovolt amps values. So, we add 7 kilovolt amps for the range, 1.2 kilovolt amps for the dishwasher, 0.6 kilovolt amps for the garbage disposal, 21.6 kilovolt amps for the air conditioning, and 2.5 kilovolt amps for the hot water tank. Adding these together, we get a total of 32.9 kilovolt amps. Step 3 is to convert the kilovolt amps to amps. The formula to use is amps equals kilovolt amps divided by the quantity 1.73 times volts. Assuming a 240 volt system, the calculation is amps equals 32.9 kilovolt amps divided by the quantity 1.73 times 240 volts. This gives us approximately 381 amps. Therefore, the total load for the multi-family building calculated using the optional method is 381 amps. It's important to note that the optional method often assumes a power factor of 0.85, which is used to calculate the ampere draw from the kilovolt amps load. Also, the standard method may not be typically used in some jurisdictions for residential load calculations. Always refer to the specific codes and guidelines for the jurisdiction in which you are working to ensure compliance.